Hey students, this is Wednesday, the 24th of February. We're taking a look at the Desmos Activity today. A lot of information in there. Going to try to slow this down. Probably need at least one of these. So let's start with the do first. Open up your Desmos. Take a look at this, pause it, and try it out. What we see is we have a geometric sequence below. 6, 36, 6, 1, 216. Geometric sequence, what does that mean? It means it's increasing by some multiplication, right? We're multiplying by some number. And so what is that? Well, see if you find it out, and then if you do, what are the next three terms, all right? And so what I found is I said, to get from 6 to 36, I need to multiply by 6. 36 times 6, yeah, that's 216. So then I multiply by 6 again, I got 1,296, then 7,776, and then finally 46,656. Geometric sequence means it's going to be an exponential function. So I want to look at these. I have 6 times x plus 6 and 6 to the x power. I saw a lot of students today think that it would be this first one because we're multiplying by 6. Well, we are multiplying by 6 in the second function too. It's just it is repeated multiplication. All right, and so it's not going up by adding by 6 each time. So if you are stuck and you're not sure, you can always test our solutions in here. And to test those, right, we just plug in our first term in for x. So we should get back a 6. If I plug 1 in for x, I get 6 times 1 is 6. 6 plus 6 would be 12. So that doesn't work. If I plug 6 to the 1 power or 6 to the first power, I get 6. And that does work. You can do it again. I don't know why this is showing up. Sorry about that. You can do it again by plugging in the second term. If I plugged a 2 in here, I get 6 times 2 is 12. 12 plus 6 is 18. That's not 18. If I plug in 2 into this function, 6 to the second power, 6 squared is 36. So that is one way of testing out an answer to find it. All right, let's move quickly forward. We're going to head to slide 8. These notes need to be in your notebook. I talked a little bit more about this in yesterday's video, so go ahead and go back to yesterday if you want to walk through this question. I also talked about slide 9 in yesterday's video, so go back to the end of yesterday's video, 223, and I walk through all of these tables by getting the growth factor. If you want to just check your answers, hit pause. I'll walk through these answers here. Answer to the first one should be f of x is 1 times 3 to the x power. Table 2 is 1 times 5 to the x power. Pause it and try out table 3. Come on back here. Here I know the growth factor is 1/2, so I have 1 times 1/2 to the x power. All right. Again, questions on those, come and join. Office hours, walk through these again. You got this. All right. So if you take a look here at this piece, I want you to look at Alexis's problem here. So it says Alexis is creating an equation and a graph for the following arithmetic sequence. Arithmetic sequence, remember, that means it's going up or down by a constant rate. Our rate of change is a number that it's either adding or subtracting by. Can you see what it's going down by? 15 to 11, 11 to 7, 7 to 3. Okay, it's going down by 4 each time. And so Alexis did a great job of writing this equation, f of x equals negative 4x. The problem we have here is the plus 15. What you have to remember about a sequence, right, is that a sequence does not include the initial value, right? We have term 1. So when we look at her graph, she has 0, 15, but that ordered pair should be 1, 15, right? It's the first term. So if I plug in f of 1, I should get back 15. And so since we see it's going down by 4 each time, we need to go back by 4 to find our initial value. The initial value should be 19. All right? And so our function is correct with everything except that initial value, it should be plus 19. Take a look here. And I already gave you away this answer, but what I want you to do is I want you to look at sequence A, B, and C. Walk through. Remember, the initial value is not there. This picture is our first term of the sequence, second term, third term. So you need to find how it is changing, what's the rate of change or the growth factor, then find the initial term. So pause it and try it out. All right, so did you try that out? I'm going to just grab this sequence right here so I can write on here a little better. What you should have seen, right, is we have 5 tiles in this first one. So our first term is 5, our second term is 7, and our last term is 9. You can see we're going up by 2 each time, right? Plus 2, plus 2. What type of sequence is this? Well, if we're adding to go up, it's an arithmetic sequence. And so we're adding 2 each time. So I can go backwards 2 to find my initial value of 3. Right? That's our figure 0 if you remember going back to our tile patterns. All right, so my initial is 3. My initial value is 3. Y-intercept. All right, and my growth or slope is 2. So f of x is going to equal 2 times our input plus our initial value of 3. Make sure you have that written down. And let's move on to the next one. Oh, where is that at? All right, take a peek at sequence B. Again, you're looking for, is it linear? Is it exponential? So is it an arithmetic sequence? Is it going up by adding or subtracting by the same number? Or is it a geometric sequence? Are we multiplying by the same thing each time? Hopefully you see from 6 to 10, 10 to 14, we're going up by how much? Yeah, we're going up by 4. So I can go backwards to find my initial value. All right, so you see if you can write this equation once you find the initial value, and then you find its rate of... All right, so did you see that our rate of change is adding 4 each time? So how do you find that initial value? Just go backwards 4, and you should have an initial value of 2. When x equals 0, we get back 2. So we're going to follow this form for a linear function. G of x equals mx plus b. My initial value is 2. My growth is 4. And so I have this equation built, or this function built, g of x equals 4x plus 2. All right, so let's look at sequence C. Now, sequence C just looks a little bit different, doesn't it? Hopefully, as you look at this, you're, okay, do I have a rate of change or do I have a growth factor? Well, if I had a rate of change, that would mean I'm adding 12. Well, 4 plus 12 is 16. Add 12 again. 16 plus 12 is 6. No, it's not. 16 plus 12 is not 64. So this is not an arithmetic sequence. What could I do to get from 4 to 16? Yeah, I could multiply by 4. And so I'm multiplying by 4 all the way through here. So I have a growth factor of 4. But what's my initial value? My initial value is not 4, right? This is our first term. So how do I go backwards to find my initial value? Well, I undo, right? If I multiply by 4 to go this way, I could divide by 4. 4 divided by 4 gives me my initial value of 1. And so our exponential function, right? A times b to the x, where a is our initial value, b is our rate, our growth factor. And so I have the function h of x equals 1 times 4 to the x. All right. So here we are on the next slide. We're looking at the sequences. So we've given you the sequence. Now we want you to give us the first 3 terms of the sequence. And just like when we were testing and plugging in to find different points on a graph, we're using these as point testers, right? We're plugging in the first 3 terms. So you can see this first one's already done for you. We plugged in 1, 2, and 3 into this function, and we got back 6, 2, and negative 2. So if you saw this as a sequence, you would see it as 6, 2, -2. And you would say, oh yeah, that's going down by 4. And look, it's going down by 4. Where do we get the 10? Well, that would be the initial value if we went backwards by 4, all right? And so we have this function, -4x plus 10. So let's try it out with h of x. Go ahead and pause sequence B, pause this, see if you can find those first 4 terms. All right, you're back, you paused, you tried it. So here we go. H of 1 equals 2 times 1 minus 7. 2 minus 7, well, that's -5. So my first term is -5. H of 2 would be 2 times 2 minus 7. That's 4 minus 7. 4 minus 7 is -3. Oh, -5, -3. It looks like it's going down by, or going up by 2 each time. Well, and that would make sense. 2 is my rate of change. So I'm not even going to do the next one. I'm going to say, you know what, it's going up by 2. That's got to be -1. And if I want to get crazy, I could keep going up by 2 and make this sequence as far as I want. All right? So now, if we're going to describe this, right, I know this is an arithmetic sequence because this is a linear function. All right, nice work. Let's move on to the next one. We're down here at sequence C. All right, I want you to try that one out on your own. All right, come on back. Well, here it is. The first 3 terms, and I put 5 there, but the first 3 terms are 2, 4, 8. All right. How do we do that, right? Maybe you want to check that out. So let me grab a clip here. Well, just like our other point testers, I'm going to plug in that first term, g of 1. Anywhere there's this x, I'm going to go 2 to the first power. Well, 2 to the first power is just itself, 2. G to the second power means g squared. That's 2 times 2, which is 4. G to the third power is 2 to the third power. And a lot of people see this and they say 6, but it's not 2 times 3. It's 2 3 times. 2 times 2 is 4. 4 times 2 is 8. Let's do one more just for fun. G of 4 then would be 2 to the fourth power. 2 times 2 times 2 times 2, which is 16. So hopefully you're seeing as you go up, right, we're just multiplying the previous term by 2 each time. Right, you're doing awesome. Keep it up. And you can see my description is it's a geometric sequence. I know that because I multiply 2 each time to get to the next term. So that growth rate, that growth factor is 2. We also call it what? Right? R ratio, right? All right. And so I'm going to let you do this last one all by yourself, and I'm going to type those in just a second. So go ahead and try that. All right, do you have something like this? Right, the first 3 terms should be 13, 10, and 7. I can see it's a linear function. We're going down by 3 each time. And I see my starting value, my initial value of 16, that y-intercept, and then 3 less than that is 13, 3 less than that is 10, and then 7, 4, 1. You got this. Nice work. All right, so here we are on slide 13. We're looking at a couple of tile patterns. So how many tiles are there in figure 1, figure 2, and then the description says figure 3 has 125 tiles. So if we're going from 5 to something to 125, I could tell right away that it's not going to be an adding or subtracting thing, right? We're not going to increase by 5 to whatever this is, right? This looks like 5, 10, 15, 20, 25. 5 to 25 to 125 in a linear function. So it has to be exponential, right? And that's the thinking that I need you to have. I can see we're going from 5 to 25 to 125, all right? I can't type. And can you see there's a multiplication problem happening there? 5 times what is 25? 5. 5 times 25? 125. So our growth factor is 5. Now how do we find our initial value? Well, if it's going up by 5 each time, go backwards by 5 from figure 1, and you can say 5 divided by 5, our initial value is 1. And so we're going to